Hello, welcome back to the video lecture series for Introduction to the Art of Programming using Scala. This is our fourth video working on our little networked game of Tron, and hopefully it'll be our last one. We should be able to get through this in this video. So to remind you of where we are, we have a server and a client, and we set them up using RMI. So they have these purely abstract traits that specify the remote calls. Our server is actually where the game gets run. And most of the methods that are in our server right now are implemented. There is just one little thing that's missing where we check if the players are dead. So right now when we run this, to remind you of where we were, if we run the server, it just runs, no real output from it. We run the first client, pops up a window, and our client prints out what number they are. So this is player 0. This is player 1, and they move. Okay, and so most of the activity is actually happening on the server. When the server gets the second player, it starts saying, "Hey, they're active," and it goes. However, the game doesn't really work in the sense that no one can win. We also have this little problem with exceptions being thrown when one of the players disconnects. And so we want to continue adding functionality. Our server has calls in here for the turn left and turn right, but we're not actually using them yet. We would have to be getting key presses. So let's go ahead and let's add that in here. I want to I'm going to listen to two things: mouse clicks and keys. The keys is what I really care about, but you should recall that one of the problems with keys is you have to have focus, and while we can request focus, it's always nice to have it so that if somehow the panel loses focus, the user can regain it by either doing a mouse clicked, in which case I want to request focus. Let's go ahead and let's import that. I'm going to put an underscore here so that I don't have to do explicit imports for the other one. In addition to mouse clicks, it's also really helpful if mouse entered also request focus. But the information we really care about is the events for key pressed, maybe key released, not really. We're most interested in the key pressed event. I'm not using key typed because that little problem that key typed has where it doesn't get things like arrow keys. Key typed only works for normal keys. We use key pressed and key released when we want any special keys. So I want to do e.key match on some cases here. One case would be key.up, in which case they have, actually no, we're just going to do a left and a right. Left goes to send server dot, is it called server in here? Let's check this. Oh, and where do we have the server? Indeed, we have the server out here. We need to work on our scope a little bit here. I'm going to go ahead and move my server code out to there. So now server dot turn left, and this is our player number, which is why I also had to move player number out to that scope. the right button should turn the player right. Okay, now if we just come down into here after we open our frame, I really don't care about printing that out. I want my panel to request focus to start with, so that it will have that focus initially. And now what about these other methods? In some ways these aren't needed for the game to work. It might be nice to have them in there so that once one player wins, the other player finds out who won. These are going to impact the paint, because really the only good way that we have of communicating with the player is through the paint. So I'm going to create a var up here. By the way, a lot of these things should probably be switched to private because they really shouldn't be accessed from outside of this class. This is such a small example, I'm not going to worry about that too much, but if we had a larger application, I would want to make a lot of these things private. Var message is an empty string. And so then g.set paint color.white, g.draw string. How about we draw it at 200, 250, and the string will be message. Okay, so now whatever gets set to be the message, we will wind up displaying. And so inside of these extra methods here, so in the case of game ends, well, if the winner that was passed is you, then, and actually let's go ahead and just do it this way, we'll do it as an expression, message equals you won, you lost. Panel dot repaint. Okay. In the game start, we're getting sent a count. Message equals count dot to string. Panel dot repaint. Currently I'm not calling either one of these from the server. Let's see if this runs at this point though. Once again, whoops, let's go ahead, make sure all of these are done. Okay. Start off with our server. Then we run one client. Move that client window over here so we can get to it again. Run another client. Well, that was interesting. So something died down here in the bottom. This is in the server, a null pointer exception over here. Oh, this happened before the panel. If panel not equal null. And the way this works, it technically is possible as soon as we've connected to the server, it's possible for the server to start sending us messages. And so even before we manage to get a window open or even create the panels. Okay. Close, close, run this, come to the client, run one client, run another client, and so I can turn. We can move around. We still don't die. Okay, so the blue can go right through the red and we don't have a problem. This 0 here is interesting. How about we go ahead and inside of the take step we set the message to 0 or to blank. Okay, That way we don't get that 0 right in the middle of the screen. The 0 was happening because apparently we are calling. So our start game method gets called when the second player connects. And yeah, this counts down way too fast. Thread dot sleep of 1,000. Okay, that's why we didn't see a countdown. It basically immediately went from 0 to 5 as fast as the program could go. Okay, so now we get a countdown. Now all we have to do is check, and our players can turn, and all sounds great. All we have to do now is check to see if they've died. Now, the way that this is currently working, the only information that we have about the players is in this. We have these two mutable buffers that contain their XY locations, and every time we add new XY locations. It would be possible to go through and make sure that our location doesn't hit any of these things, but it will be much faster if instead we decide to create another value. And I'm going to make this array.fill 500 by 500 of false. I don't really care who's there for this application. If we had multiple players and we wanted it so once one of them dies, their wall goes away, which is actually what happened in the original Tron movie, then we would want to make it so that this can do something else, give it ints or whatnot. But I'm perfectly happy making this an array of booleans, and if we hover over, you can see this is an array of booleans, where I look up the x coordinate for the first and the y coordinate for the second. And so then every time that they move, I want to add that point into here. So first I'm going to set board, well actually no, so first they've just moved, we move them, we add those things to the list. Now we need to do a check. If board sub clients sub 0.x sub clients sub 0.y, it's a boolean. So if it's true, then this means that player 1 died. Winner equals 1. Else if, and we'll do the same thing, except for client sub 1, winner equals 0. Semicolons again. I've been programming in C++ recently. Okay, so that checks to see if they're dead. When we get down to here, now we need to fill in those spots on the board. So copy, paste equals true, paste equals true, except for number 1. And we send each one the winner when the winner is not less than 0. Okay. One problem with this. What happens if they go out of bounds? Well, right now if you go out of bounds, this crashes. So we have to include in here not just a check that you ran into something on the array, we also have to say you're also going to die if the x coordinate is less than 0 or the x coordinate is greater than or equal to 500 or the y coordinate is less than 0 or the y coordinate is greater than or equal to 500, or what we have there, and we can copy this, paste, and change the zeros to ones. I'm not exactly happy. I still have these magic 500s in here. There's 500s that appear here, 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 and here, as well as in the board, and also in the client when we create the image. These would be things that I would like to define someplace as a variable in a better implementation of this. Start up one client. Nope, that's not going to work. Start up a second client. 5, 4, 3, 2, 1, 0, go. Okay. So there's the red. Blue. Boom. The blue lost, the red won. And we're done. Okay. So we kill that, and we kill that. And it turns out the clients go away very nicely, and the server doesn't crash if all of the clients disconnected after the game was over. So that's it. That is our RMI based game. There are lots of things in here that we could do for making it so that the code was more robust if people disconnected and it handled that situation better, but we're not going to focus on that now. Hopefully through this example you've seen how we can use RMI to set up communication between two machines and to do something similar to playing a game, which you can extend to all other types of applications.